everyone. This is Professor Chan from Math 1245. Today we're going to be going over section 3.5. We're going to continue on. We're just going to talk about how to graph rational functions by hand. Okay, as you can see below, okay, you're going to find a bunch of different aspects of your rational function. Okay, one thing to keep in mind is as you're doing your homework online, okay, you will not need to do this because they will ask you, well, they'll just give you a bunch of pictures, right, and then you'll kind of match them. But one thing in particular on the midterm is you may be asked to kind of do this by hand, okay? So I'm going to show you several examples how to do this, okay? And there's a lot of different steps, but the more you practice, the more you'll get better at this. And then also in particular, on the midterm, if you're being asked to do this, I will ask you all the different characteristics of these things, so you don't have to memorize them all. Okay. So the first thing is we want to see what my domain is. So I'm going to set. Remember, how do I find my domain? I set my bottom equal to 0. So I have x is equal to 4. So my domain is going to be x such that x does not equal to 4. Okay. Now let's talk about what that is, right? Because I'm not canceling this. Okay. Well, the first thing is we want to make sure we factor this. So this is factors of the x plus 4 and x minus 3 all over x minus 4. Okay. So if you notice, it's not canceled. So I should realize x equals 4. That is a vertical asymptote because it doesn't cancel. Remember, if it's canceled, right, that's called a hull. Okay. But yeah, so always make sure you write this in lowest terms, okay, for the following here. Okay. And then I can find my intercepts. Okay, so how do I find my intercepts for the following here? Let's talk about the following, right? So if I want to find my x-intercepts, you're going to set the top part of your fraction equal to 0. So I'm going to set x plus 4 equals 0, and I'm going to set x minus 3 equals 0. So I have x is equal to negative 4, and x is equal to 3. So I have negative 4, 0, and 3, 0. Okay? So you have the following here. Let's talk about how I graph this. So I have a coordinate at negative 4, 0, 3, 0. Okay. So negative 4, 0 is right here. And then 3 zeros right here. And then I have a vertical asymptote at x is equal to 4. So I'm going to draw a dotted line. Like this. So I say I have a vertical asymptote at x is equal to 4. Okay. Okay. Let's also look at the following. Again, I already got my vertical asymptote, so I have x is equal to 4. And then let's look at my let's look at my y-intercept. My y-intercept, remember, is when x is equal to 0. So I plug this into my reduced form. So I have 0 plus 4 times 0 minus 3 all over 0 minus 4. So this is negative 12 over negative 4, and that equals 2, 3. Okay, so I have a y-intercept at 0, 3. Like this right here. Okay. Okay, so let's look at this here. So the other thing we want to look at is the last thing we want to look at is what kind of asymptotes we have, whether it's horizontal or oblique. Yeah, and one thing I want to mention that I forgot to mention in the past video, you can only have either a horizontal or an oblique. You actually can't have both, okay, for the following here. So now let's look at what I have. I have x squared plus x minus 12 over x minus 4, right? I can write it in reduced form, but that's actually not helpful to me. And technically they're the same because nothing cancels out anyways. So x squared plus x minus 12 over x minus 4. I realize the degree on top is greater than the degree on the bottom by 1, so that will make it oblique. Okay, so what I would do is I'll do long division. So I have x squared plus x minus 12. And I have x minus 4. So I'm going to multiply x by, I want to see what I would multiply x by to get to x squared. So that'll be x times x is x squared, x times negative 4 is negative 4x. And then I'm going to subtract. This is 5x minus 12. So it'll be plus 5. So this is 5x minus 20. Subtract. This is going to be positive 8. So I have y is equal to x plus 5 plus 8 over x minus 4. This will go to 0. Okay. So I have an oblique asymptote at x plus 5. So let's look at this right here. So remember, x plus 5, if I draw this, right, that means I have a y-intercept at 0, 5. Okay, make sure you know how to graph lines. Okay, it's a good thing I caught this. It's actually, sorry, 0, negative 4, 1, 2, sorry. Oh, no, I was correct. Sorry about that. Sorry, 1, 2, 3, 4, 5 is right here. And then you have a, there we go. So I have an oblique at y is equal to x plus 5, okay? Let's talk about your asymptotes. So remember, your asymptotes, your graph cannot cross at all, okay? The only exception is horizontal. There are a couple of exceptions. So vertical and oblique, it will never cross. But horizontal asymptote, you can actually cross in the middle sometimes. But as you go towards the end, it should never touch or cross your horizontal fence. Yeah, but so for the most part, think of them as invisible fences that they're essentially boundary lines that your graph can't cross. Okay, but once again, the only exception is horizontal asymptotes. It could cross in the middle, but as you go towards negative infinity to positive infinity, it should not cross. Okay, so if you look at your picture here, right? My graph goes through these 3 points. It can't cross these lines, dotted lines. So it's going to look something like this. Okay, we're fine. Just do the best you can. So the blue part should get closer to your asymptotes, but actually doesn't cross. And then there's going to be one here. Okay, generally, your graphs tend to kind of, so when you have multiple asymptotes, right, you'll have different regions. Generally, your graphs will kind of move diagonally. So if you notice, I have 4 little sections. And so if you notice, it's like the bottom left and the top right that the graph will be filled, okay? Now, here's the thing. If you're not sure if you did this correctly, use your graphing calculator to check. So let's take a look at this here, okay? Don't worry too much about the shape. Focus on where it kind of ends and leads, okay? So I have, make sure you put this in parentheses, x squared plus x minus 12 divided by x minus 4. Now I'll hit the graph. Sorry, I need to do zoom 6. So let's take a look, okay? So it looks really similar, okay? I am missing the top right. Let me show you if I zoom out. So you can see there's definitely a kind of a top right, okay? Now, here's a thing to also keep in mind, right? As you can see in your graph, okay, they will not graph your asymptotes. But if you notice right here, you kind of see where my pointer is pointing at, right? I can see that there's kind of this like random slope, and that's actually my oblique. I also know, right, there's kind of this like, I notice my graph kind of slopes down, and next to it, that's my vertical asymptote as x equals 4. I can also see my intercepts work. I have 0, 3. This definitely looks like it's 3, 0 right here, very close to it. And if I scroll over here, this is definitely going to be negative 4, 0 or close to it. Okay. So you can do second trace, also remember, and do value and type in negative 4. And you have negative 4, 0. Okay. So yeah, that's pretty much it. Let's continue with a couple more. I'm going to scroll down and I'll do yeah, let's jump to example like number 3. Yeah, I want to do number 3 anyways because this is kind of an odd looking one. So let's take a look at number 3 here. And we are going to find our domain. So remember, what I'm going to do is I'm going to factor the bottom and the top if possible. So the bottom factors are x minus 1, x plus 1. I set them both equal to 0. And I solve for each one. So I have, x plus 1 equals 0. So that becomes x equals negative 1. And I have x minus 1 equals 0. So I have x is equal to 1. So my domain is going to be x such that x cannot equal to 1 or negative 1. Now notice once again, both of these do not cancel. So I realize I have a vertical asymptote at both x is equal to 1 and x is equal to negative 1. So I will have a dotted line for both of these. Okay. So what we're going to do next is I'm going to find my intercepts. So let's do my x-intercepts. That is when y is equal to 0. So you'll set the top equal to 0. So I have x is equal to 0. Right, divide both sides by 3, and I have x is equal to 0. Sorry, let me redo that part. So here's the thing. I actually have an intercept at 0, 0. That means that's my x and y intercept. So I have an intercept like this right here. Okay. So I got my vertical asymptotes. I got my intercepts, both x and y. And then now I want to figure out my asymptote, whether it's horizontal or oblique. So let's look back here. So notice I have 3x over x squared minus 1. Okay. So if you take a look at this here, this is degree of 1. This is degree of 2. So because of that, remember my rule is I have a horizontal asymptote at y is equal to 0. And it looks like this. Okay. So it looks like the following here. Okay, now this is where it looks kind of odd. Okay, so if you notice my intercept is directly on my horizontal asymptote. Now remember what I said before, it's okay, it can cross or touch towards the middle, but as I'm going to the left or right, my graph should avoid that. Okay. Now this graph looks kind of weird. Some of you guys are like, how the heck am I supposed to graph this? Okay, just use your graphing calculator and just follow along. So I just want to graph and see if my graph makes sense based on what I see. So once again, put the top in parentheses and then put the bottom part in parentheses. Okay, so here's the thing. Okay, so let's take a look at our calculator graph. As you can see, right, there's like this invisible boundary here. That's -1 and 1. And I also notice it kind of flattens out as it goes aside. That makes sense because at y equals 0, I have a horizontal asymptote. So let's look at this here. So even though I didn't graph my actual graph, right, my boundaries do make sense, and it does cross at the intercept, which I said it would. So it looks like this. Notice it's always going to, your graph is always going to kind of hover close to your asymptote, but it's not going to touch or cross towards the end, okay? Now, here, remember your horizontal asymptote, it can cross towards the middle, which is very possible, okay? So right here, it does cross, okay, for the following, okay? But as you go towards the left and right, as you can see, it should not touch or cross your horizontal asymptote. Okay. Let's do another example. Let's see. Let's do number 2 for the following here. Okay, so we're going to do the same thing once again for the following. So we're going to factor everything out, and we're going to reduce. So let's take a look at this here. So this becomes, the top becomes 4x plus 3, and then 2x plus 5. This factors a 2x plus 5, and then x minus 3 here. So one of the things I realized in this, right, is I noticed that these two factors can cancel out. So my remaining form is 4x plus 3 times x all over x minus 3. Okay? So this cancel part, remember, we're going to set that equal to 0. And I have x is 2x equals -5 divided by 2. X is -5 halves, which is actually just -2.5. I'm going to keep it as a decimal so it's a little bit easier for me. So I'm going to plug this in. So I have 4 times -2.5 plus 3 divided by -2.5 minus 3. So that is -10 plus 3 all over -5.5. So -7 divided by -5.5. So that reduces to 1411. Or you can say approximately 1.27. Okay, so I have, this is a hole at negative 2.5 to 1.27 approximately. You can leave it in fraction form or decimal form based on what your homework wants you to do. So let's graph this. So negative 2.5 and then 1.27. So I'm going to draw an open circle like this. Okay, that's how I would graph a hole. So remember what a hole is things that will be canceled. You'll find your x value and then you plug it in. Remember, plug it in into your reduced form. Don't plug it into your original because it actually won't come out correctly. Okay. Next thing I realized is I have a vertical asymptote, so whatever is left over, I'm going to set x minus 3 equals 0. So I have x is equal to 3. That is a vertical asymptote. Okay. So, and then I'm going to look at whatever I have a and then I'm going to look at my intercepts. Sorry, I got a little ahead of myself. So let's look at my x-intercepts and my y-intercept. Now let's talk about this. If you want to find your intercepts, okay, do it after you reduce it, okay? So we're going to use our reduced form for x plus 3 over x minus 3, okay? I don't want to use my original because 2x plus 5, as you can see, doesn't exist technically because it got canceled out. So I'm going to set the top equal to 0. And I have 4x equals negative 3. Divide both sides by 4. I have x is equal to negative 3/4. So I have an x-intercept at negative 0.75, comma 0. And then my y-intercept, remember, is when x is equal to 0. So I'll plug in 0. R of 0 is equal to 4 times 0 plus 3. And then 0 minus 3, which will give me negative 1. So I have a y-intercept at 0, negative 1. So I have negative 0.750, which is like right here, if I'd approximate, and then 0, negative 1, which is approximately right here. Okay? We're following. Oh, sorry, negative 0.75 is like right here. Sorry about that. We're following. Okay. Everyone got that? Make sure you pause this because I'm going to erase this just because we don't have enough room. So I'm going to erase this right here. Okay. So actually, my bad. I probably should not have. Okay. Sorry, I should not have erased that last one. So let's remember, right? It reduces 4x plus 3, 2x plus 5, 2x plus 5, and x minus 3. So this cancels, okay? So when I look at my horizontal asymptote, I look at my reduced form, right, which is 4x plus 3 over x minus 3, okay? So what I can do is I'm going to do long division, or I could do synthetic. Either one's fine. Okay. Oh yeah, always use your reduced form rather than your original if things cancel out. Okay, so I'm like, what does x multiply to get me 4? That's 4. I should realize I have the same degree, so I should actually just have a coefficient. So I have 4x minus 12, but I can still use long division. And I get 15. So y is equal to 4 plus 15 over x minus 3. And then remember, this goes to 0. So I have a horizontal asymptote at y is equal to 4. So at 1, 2, 3, 4. Let me use a different graph. Sorry, different color. So I have y is equal to 4 as a horizontal asymptote. And then I have x is equal to 3 as a vertical asymptote. Okay. Now look at where your graph is kind of going through, right? It goes through these 3 points, and it can't cross these 2. So it should look something like this. Now, because I have a hole right here, it's going to skip. Okay? And then it'll continue on, and then I'll have something like this on the opposite side, okay? So this is what my graph should look like. And then once again, how do we know we're correct? Try to use your graphing calculator to check this out. Always put the top in parentheses and then the bottom in parentheses as well. Okay, so that makes sense, right? I can see that at y equals 4 here, right? I can clearly see that there's kind of this invisible line here. I know it's going through the following, okay? So it kind of matches, right? I can clearly see there's also a kind of invisible vertical line right here, which is at around x equals 3. Now, one thing I do want you guys to take notice here is if you notice, there is no hole. Your calculator is not sophisticated enough to graph a hole. So if you notice, there is no gap in your graph, okay? So how do you check? Just use your table, or you can use the value, right? So you can use second trace, and I'm like the value, and then you're like, well, what happens when x is equal to negative 2.5, right? So I type negative 2.5 here, and notice nothing comes out. Notice I don't have anything at y. So that means it doesn't exist, okay? So that means I have a hole there. So that's what you have to do analytically, okay? But for example, if I show you like at x equals 3, notice it does give me, sorry, when I plug in like x equals 2, it does give me a y value, okay? Now, if you notice, when x is equal to 3, why it doesn't work, and it disappears, well, that's because I have a vertical asymptote, so that's why it doesn't exist at that point, okay? So I'm going to show you one last example, okay? So you may see something like this, okay? And this will be helpful for your concept check. So yeah, let me show you something like number 2. So number 2 is going to be the following, okay? They're going to give you a graph, and you're going to figure out how to write your rational function, okay? So this is what you're going to do, okay? The easiest thing that you want to do is you want to actually do the following. So let me read this off. You guys should have your packets here, but idea is look at all your different aspects, list them out, and then write them in terms of the factorings for the following. Okay. Yeah. So let's look at what I have. Okay. So I have a vertical asymptote at x is equal to 1. I have a horizontal asymptote at y is equal to 1. I have a x-intercept at 3, 0. And I have a y-intercept at 0, 3. And then I also have a hole at negative 1, 2. Now, I'm more focused at x is equal to negative 1. Okay? So that is everything that I listed out. So what do they mean in terms of my function, in terms of my f of x? So if I have a vertical asymptote at x equals 1, let's talk about what that means, okay? Actually, so the three that you always want to focus on first is your holes, your x-intercepts, and your vertical asymptotes. So if I have a vertical asymptote at x equals 1, remember, what does that mean? That means that's where it doesn't exist on the bottom. And so remember, if it's x equal to 1, remember I put x minus 1, like the following on the bottom. Okay? X-intercept, remember, that is my 0. And remember, how do we do zeros? We go opposite. So if it's plus 3, I'll do x minus 3. Okay? And then since I have a hole at negative 1, 2, at x equals negative 1, remember, holes cancel. So I'm going to type it in as x plus 1 on top and on bottom here. Okay? Okay. So hopefully you guys have all that figured out. So you always want to set up your vertical asymptote, x-intercept, and hole in terms of its factors. So that's the first step you'll do. Step 2 is you're going to look at your y-intercept, okay? So we want to see if it works, because if I plug in 0, I should get 3. So let's do this. If I do f of 0, I get 0 minus 3, 0 plus 1, over 0 minus 1, 0 plus 1. This is negative 3 over negative 1, which is 3. So that works. So my y-intercept works for the following here. Okay? Okay, so I'm going to erase this. Yeah. So the last thing I want to see is if my horizontal asymptote works out, okay? So I'll distribute this. So I have x squared. If I distribute this, this is plus x minus 3x minus 3. So this here becomes just negative 2x. And then this one I distribute will become x squared minus 1. So let's talk about this. This will be a horizontal asymptote, and if I look at these two, they cancel out and I'll get 1, right? You can also do long division to check, but I have a coefficient of 1, so that works out as well, okay? And then again, if you're not sure, graph it. So this is what we're going to do, right? Let's graph the following here. So I have, do double parentheses, x minus 3, x plus 1. So as you can see, notice I'm grouping both parentheses because they're on top together. And then I'll do the same for the x minus 1, x plus 1. You can also just graph the one when we distributed this. Okay. So that looks pretty close to the following here, okay? And that's it. So yeah, keep practicing this. One of the things is make a list of all the things you need, okay? And remember, you also have your graphing calculator check. You do need to show your work, okay, for the following if you're being asked to do this on the midterm. If you have questions, let me know or post in discussions. But other than that, I'll see you guys later.